On a moonless dark night, a faint band crosses the sparkling vault of sky. At first, it seems like a cloud or a stream of smoke blown by a strong wind. But it stands still among the stars, for it is a permanent and more fascinating feature than a fleeting cloud. The Romans called it PlanetX, meaning the Milky Road or Milky Way. To astronomers across the ages, it has proven to be a pathway to discovery. To ancient sky watchers, the Milky Way was a mystery that became myth. Some saw it as the frothy wake of a celestial ship. Others thought it was where the two halves of the sky were sewn together. But these stories and myths leaned more towards the storytellers than an understanding of the Milky Way's true nature. For the ancient Greeks, the Milky Way formed when the goddess Hera woke to find the strange infant Hera thus nursing from her. The divine milk bestowed immortality. But when Hera realized she had been tricked, she pushed the child away, causing milk to spray across the sky. To today, the word galaxy originates from the Greek word for milk. But beyond the tale, the true nature of the Milky Way remained concealed until humans saw it through a telescope. That was in 1609 when Galileo Galilei first directed his new invention towards the nebulous light of the Milky Way and recorded what he saw. Galileo discovered that the Milky Way was made up of countless stars, too distant and faint to be seen individually. Together, they dotted the night sky with their collective light. This realization changed everything because it added depth to the night sky and meant that astronomers were free to explore the celestial kingdom that the ancients never dared to dream of. Galileo noticed that the stars of the Milky Way sometimes blend together, and as telescopes improved, astronomers discovered something else: the bright glowing gas clouds called nebulas, which later proved to be the birthplaces of stars. Many of them lay along the Milky Way like jewels against the cosmos necklace. Even though telescopes revealed hidden objects in the Milky Way, they left a big unanswered question. Why was the Milky Way confined to a narrow band one around the sky? It would take another century and more after Galileo for someone to come up with part of the answer. In 1705, William Herschel, a journeyman musician and amateur astronomer working in England. His plan was simple to understand, but laborious to execute. Pointing his telescope to over 600 different locations, Herschel began counting every star he saw in each area and estimated the relative brightness of each star. He assumed that fainter stars were further away and brighter stars are closer. By putting them together, he painted a picture of the universe as follows. It showed that we are attached to a large system of stars shaped somewhat like a gigantic hat or disk. In some directions, stars are relatively few in number, but along the middle of the disk, the stars start to crowd together. Their combined light forms the band of light of the Milky Way. Here's map was a significant step forward, but only the tip of the cosmic iceberg, for beyond the limits of Herschel's telescopic view, a much larger Milky Way awaited discovery. Based on William Herschel's work, 19th century astronomers further confirmed that our sun is part of a stellar band that forms a giant disk, explaining why we see the Milky Way as a bright band stretching across the sky. But astronomers were not completely satisfied with this rudimentary picture of our galaxy, because it implied that the solar system was near the center of the Milky Way, a coincidence that seemed highly improbable. And without a standard way to measure distances to the stars, it was impossible to know how accurate the picture of the galaxy was. To understand the Milky Way better, astronomers needed new tools and ideas. In 1912, they had both. A new idea was a way to directly measure distances in the deep universe, and its discovery was entirely by chance. In the era before electronics, Henrietta Lannert was one of several women hired by the Harvard College Observatory to do mathematical calculations. At that time, a large amount of data had been streaming into the observatory thanks to the development of astronomical photography. Women working as computers at Harvard did not think they would make their own scientific discoveries, aided by the unprecedented power of the telescope. Harlow Shapley, a journalist specializing in crime stories, who turned into a professional astronomer, would go into the history of the Milky Way about to use a giant telescope to observe globular star clusters, distinctive spherical groupings of stars. Each cluster contains hundreds of thousands or even hundreds of millions of stars orbiting each other like a swarm of bees. Shapley believed that these clusters would orbit the gravitational center of the Milky Way. By using Cepheid variable stars to measure distances to these clusters, Shapley was able to determine the position of a point in the universe around which all the clusters seemed to congregate. The results changed everything, showing that the real center of the Milky Way was tens of thousands of light years away in the direction of the Sagittarius constellation. Cepheid's discovery pushed the solar system out of the Milky Way's center, relegating it to the... It was a cosmic motion, similar to how centuries before, Nicolaus Copernicus had removed Earth from the center of the solar system, placing the sun there instead. Shapley's work gave us a view of being in the suburbs of a much larger galactic city than anyone had imagined. Today, astronomers estimate the Milky Way to be over 100,000 light-years across. But even in a short year's time, there was growing evidence that this vast Milky Way was just a small part of a much larger universe. This evidence came in the form of faint objects scattered around the sky, which became the focus as telescopes evolved. Many looked like tiny smudges, others had distinct spiral shapes. To some, these hazy spirals seemed to be new solar systems forming within the Milky Way, but there was a more revolutionary possibility. Could they be entirely separate galaxies like the Milky Way, but far out in the universe? In the 1920s, astronomer Edwin Hubble was able to prove that the answer was yes, using the newly constructed 100-inch, 2.5-meter telescope at Mount Wilson Observatory. Hubble turned the lens towards the Great Nebula in Andromeda, the largest of the mysterious spiral nebulas. There, he discovered the Cepheid variable stars, once again proving to be crucial. They allowed Hubble to calculate the actual distance to the Andromeda Nebula. The results were turning points in our understanding of the universe. Hubble's measurements showed that the Andromeda Nebula was indeed a separate galaxy, lying far beyond the boundaries of the Milky Way. Today, astronomers have determined its distance to be over 2 million light-years away. Other galaxies are even more distant, millions or even billions of light-years away. Hubble's discovery revealed the rest of the universe, but it also gave astronomers a new way to think about the Milky Way by comparing it to other galaxies. The era of galaxy exploration was about to begin. By the mid-1920s, astronomers knew the universe was filled with galaxies like islands in the cosmic sea. Galaxies are separate systems, each containing hundreds of billions of stars. This new discovery raised new questions about our own galaxy, the Milky Way. Was it a spiral galaxy, like some of the systems that could be observed from afar? If so, how could we know being inside it? It would take many more decades for astronomers to confirm the Milky Way's shape as a large disk with the solar system, situated about 2/3 of the way out from the center. The challenge then became to map the Milky Way from the inside. This was no simple task, and thus was a major obstacle. Even ancient astronomers noticed that the Milky Way did not have a uniform appearance in the sky. Instead, it was patchy and irregular. In some places, it seemed to be interrupted by dark rifts, the result of large clouds of dust among the stars, obscuring most of the Milky Way's view. Despite the obstacles to visibility, there were clues that helped astronomers discern the true shape of the Milky Way. American astronomer William Morgan was one of the first to follow these clues. One night, while looking toward the constellation Perseus, Morgan realized that many of the blue supergiants he was studying in that part of the sky all lay at the same distance, between 5,000 and 8,000 light-years away. And so did the famous double cluster in Perseus. Morgan realized that the double cluster and these stars together formed a path across the universe, marking a structure embedded within the Milky Way. He had discovered the Perseus arm, one of the galaxy's great spiral arms. Now familiar sites scattered along the Milky Way also showed they were part of the Perseus arm. Among them is the spectacular Cram Nebula, the remnant of a supernova explosion recorded in 1054. But if there was one spiral arm, there must be others. By looking in the opposite direction from Basius, astronomers saw hints of another arm closer to the galactic center. This was the Sagittarius arm, home to a series of bright clusters, luminous that illuminate the southern part of the Milky Way. Magnificent sights like the Cepheid Nebula make this part of the sky a visual feast closer to Earth. Astronomers assert that our solar system is part of the Orion Arm. Yet the Orion Arm is also filled with fascinating sights that loom large before us because they are relatively close. When observing the length of the Orion Arm, we find the spectacular star-forming regions nearest to us in the sky, the Orion Nebula, where thousands of new stars are being born before our eyes, visible with the help of radio telescopes and infrared satellites. These devices can peer through the Milky Way's dim veil of dust. Now astronomers have looked deeper into the Milky Way to map its structure in detail. They have discovered additional arms and also confirmed that the Milky Way is not just a spiral galaxy, but a barred spiral galaxy. Barred spirals are common in the universe, and their appearance is the product of evolutionary processes that cause material in the galaxy to form a ball-like feature extending from the center. Over 60 years after Morgan's initial discovery of the Perseus arm, astronomers can show us what the Milky Way would look like if we could see from the outside, and this is the result. The image reveals the Milky Way as a barred spiral with two permanent arms, one of which is the Perseus arm. Across from it is the less visible from Earth Cetus Vitalis arm, which contains many large, young, and hot star clusters, such as there is displayed in the infrared light of the Spitzer Space Telescope. Adding to the scenery are smaller spiral arms winding between the two larger ones, including the arm where a solar system resides. This is the landscape that no telescope can show except one supported by years of observation across the entire Milky Way. Mapping the Milky Way is one of the great achievements of astronomy, but it is not just a map, it is also a snapshot of the dynamic star system with a history that unfolds over billions of years, a history directly related to our existence and tied to civilizations like ours. With an immense turbo desire to map and explore the universe around us, the study of the Milky Way is essential for understanding our place in the planning our future explorations in space.